and everything is changing. Moment by moment, as the shadow is passing over you, you see everything shifting and changing, and it's just an incredible and an amazing sight to see.
Yes, but
Chuck,
Joe, tell us how you really feel about
I
this.
know, that's what I'm saying. This is StarTalk. Neil deGrasse Tyson, your personal astrophysicist. Got with me Chuck Nice. Chuck, how you doing, man?
Hey, Neil, what's happening?
Okay, my co-host and comedian and actor. So today, we're going to talk about eclipses. Solar eclipses, to be precise.
Look at that.
Nobody doesn't love a good solar eclipse.
Yeah.
And the press is all over them when they occur.
Boy, oh boy.
Yeah, they can't get enough of them.
Yeah.
And, there's some interesting history of science behind solar eclipses. I thought I'd tell you about that.
Okay. I'm always down for that.
So first of all, these eclipses happen every couple of years. They're not rare, in spite of what newspapers tell you.
Yeah.
Okay.
Everybody
They're
likes
not
to
rare.
Yeah.
Okay. People want to think something happens in the sky and you're special because you're alive to see it. And
Right.
they'll say, then it won't repeat for another. Okay.
Yeah.
And it repeats in a couple of years, right?
Right.
But those it won't repeat for your location for another 500 years.
Right.
So get in a car. Okay. Well,
there you go.
okay.
Right. Yeah, basically.
All right. So in 1905,
Okay.
we'll go back. Albert Einstein publishes the general theory of relativity.
Yes.
Which allows us to think about space and time in the presence of accelerations. All right. The original special theory of relativity was for constant velocity.
Right.
You're not changing your speed or direction. So it was a simplified case. And there's a whole set of equations that go with it. But what it needed was the general case. Suppose you're accelerating. Suppose you're in a strong gravitational field. Do these equations help you with that? No. It took Einstein another 10 years to figure out how to extend the special relativity into the general case. 1915, he publishes the general theory of relativity. All right. And what it said was that the fabric of space and time is warped in the vicinity of strong fields of gravity. In fact, it's warped in the vicinity of any source of gravity, but you only really begin to notice it for strong sources of gravity, especially black holes, which weren't discovered yet or invented yet.
Right.
But in a modern example, that's the extreme case. Before this, the planet Mercury, its orbit around the sun was not following Newton's laws. Something's wrong. Are Newton's laws, do they fail? Or maybe there's another planet that you can't see that's tugging on it that we're not including in our equations. Well, why can't you see it? Oh, because, maybe it's just orbiting too close to the sun and it's always lost in its glare. Okay? So astronomers were perfectly content explaining away Mercury's anomaly by invoking a planet whose gravity was affecting it. We were perfectly happy with that. We even named the planet. We called it Vulcan.
Oh.
Okay.
Oh, I didn't know
planet
it was
orbiting
right here in our own solar system.
We got one, right?
Ooh.
All right. Well, during a total solar eclipse, the sun is blotted out by the moon.
Right.
If there's a planet orbiting close to the sun, you ought to be able to see it.
Right.
When you wouldn't otherwise be able to see it under normal conditions.
Right.
So, ever since we learned that Mercury's orbit was misbehaving, we waited for solar eclipses to look for the planet, Vulcan, and we never found it. Well, it must be behind the sun, or maybe exactly in front of. That's why,
it's rather dodgy. Vulcan.
It's a dodgy planet,
It's
all
a
right.
dodgy
So we were happy to sort of keep making excuses for it. Okay. So now Einstein's general theory of relativity gets published, and it predicts that light passing by the sun will feel the gravity of the sun and its path will be bent as it goes by.
Right.
Because of the curvature of space and time. Now I have two things to look for. Vulcan. Plus whether we're going to bend the light around the sun. All right, so this all happened in 1915. Sir Arthur Eddington, probably the world's first astrophysicist, if you wanted to. We have astronomers up until him, and after that, my boy had some physics growing within inside him, okay?
Yes.
So he said, I'm going to test this. You say the sun has such a strong gravity, it's going to bend the light of the sun. I'm going to test it. So he's going to use a solar eclipse to test it. So you want to take a picture of the star field when the sun is nowhere to be found.
Right.
Then wait 6 months. Now the sun is exactly in the middle of that star field during a total solar eclipse. And now you take an image of all those stars again and see if their positions have shifted. This is brilliant.
It is.
Okay. Well, there's an eclipse in 1916. Did he do the experiment then? No. There was an eclipse in 1918. Did he do the experiment then? No. Why not?
16 and 18, because it's like wine. An odd year is better.
Chuck, how soon we forget. The world was at war.
Oh, damn. That's right.
Access to resources and boats and ships and tools and food. The world was at war.
Wow, that's right.
So World War I, back then, the Great War, as they called it, because they didn't number them yet.
Wars.
Right.
We see how that turned out.
I know, right. So he had to wait for the war to end. So the next eclipse after that was 1919. Right. So on May 29th, 1919, he mounts an expedition to observe the eclipse. And he does so. And he makes the measurement of the positions of the stars. And he discovers, yes, the positions of the stars have shifted from where you expected them to be because they are curving in the presence of the fabric of space-time being distorted because of the sun.
Look at that.
And people said, holy cow, if Einstein's general theory of relativity is true, then let's recalculate Mercury's orbit. And when you do that, you find out that general relativity is what's messing up Mercury's orbit.
Right.
You don't need, so Vulcan evaporated overnight.
Right.
With the confirmed Einstein's general theory of relativity. So we lose Vulcan, we gain the confidence in the general theory of relativity. And it's all because of Sir Arthur Eddington, brilliant physicist. I think he was from Cambridge, England, at University of Cambridge. And he's the one who said, before he knew anything about thermonuclear fusion, he's the one who said, when people asked him, well, where do we get these heavy elements? He said, maybe they happen in the centers of stars. Well, we don't think it's hot enough in the centers of stars. And he said, maybe so, but if there's going to happen anywhere in the universe,
it would have
that's where it's going to happen.
Yeah. I mean, listen, and no disrespect to Sir Eddington, okay? It's not a hard stretch to make. I mean,
well, because we calculated the temperatures of the centers of stars,
right? And
it was not hot enough to fuse. What we needed quantum physics,
right? Which
was the decade that followed, the 1920s.
Right.
By the way, Chuck, we are living in the centennial decade of a watershed decade in the history of physics.
Right.
The 1920s, where quantum physics was developed, where Hubble discovered that the Milky Way is not alone in the universe. There are other galaxies. And when Hubble discovered that the universe is expanding.
Right.
All of that happened in the 1920s.
Wow.
Just thought I'd put it out there.
That and a bunch of drinking and partying.
The roaring 20s.
The roaring 20s.
Okay, yeah. Not everybody was roaring, at the speakeasies, right? So that's just a bit of the background physics on that particular, for that reason, it's the most famous eclipse in physics.
Right, yeah.
The 1919 eclipse.
Super cool.
So Chuck, you noticed that there was an eclipse in 1916 and 1918.
Yep.
And he got the one in 1919.
Right.
So, like I said, eclipses aren't rare.
Not rare.
Okay.
Not a
and
big
we're having
deal.
this conversation.
Cosmologically, it's a bus schedule. Like,
But
let's not
thank you.
get crazy. Let's not get crazy. Okay. Oh my God, we missed the bus. What are we gonna do? We're stuck here forever. We missed it. Like, nah, man, there's another one coming. Don't worry. It's all good.
We got this. Bus schedule. So we're recording bits of this coming on to the beginning of October. The next eclipse is October 14th.
Look at that.
Look at that.
Just,
and check your bus schedule after that. Go
right.
on, look at it right now.
Okay.
Look at it right now.
All right.
There it is. Okay. Next one, April.
Oh, okay. Mine said 420.
Is that right? What notes are around you, Chuck?
I don't know.
What are you? Okay.
Yeah. Wow. So look at that. Yeah.
Yeah. So we got eclipses coming and going. And so, well, I know a thing or two about eclipses. I have a friend and a colleague who knows more about eclipses than perhaps anyone else in the world.
Okay.
Now, how do you get to that list? I think he may be the person of all living people on Earth who has seen more eclipses than anybody else.
That is. Oh, I wonder if anybody has attempted to quantify that record.
Yeah, that's a way to quantify. So add up how many minutes in the moon shadow you have lived.
Ooh, that's the title of his book.
No, I guess that is a book title.
Minutes in the Shadow of the Moon.
Ooh,
that's a great title. Minutes in the Shadow of the Moon.
We'll tell him that when we bring him on.
Yeah.
That's right. So, so he's a friend and a colleague. His name is Joe Rao, and he's a meteorologist. He's an associate at the Hayden Planetarium at the American Museum of Natural History, and meteorologist. He actually delivered the weather. He was like the TV weatherman for in multiple places in the region, but News 12 in Long Island and I think in Westchester. Cool. But so, by the way, when you're an astronomer, you also have to be really good at knowing the weather.
Yes. Because
it's not just whether it'll rain, it's whether or not there are clouds, right? We care if there are clouds.
Right.
Whereas you can still hold your picnic under the clouds, right? So our standards for the weather that we need are much higher than that of basically everybody else.
Right.
So there it is. Eclipses here, eclipses there, eclipses everywhere.
Hey, StarTalk fans, how would you like to win a $1,500 professional telescope for free? That's right.
Today's episode is brought to you by Vayanis, and they'd like to give 10 lucky audience members their Vespera telescope for free. If you don't know Vayanis, well, you should, as they're the team that pioneered the Smart Telescope, a perfect integration of robotized telescope and camera, all while being controlled from your smartphone or tablet. Small yet powerful, and with award-winning technology, Vayanis telescopes grant access to the wonders of the deep universe, including galaxies, nebula, and star clusters, and are suitable for both observation and astrophotography, even in urban settings. As easy as 1, 2, 3, there's no need to be an astronomy expert with Vayanis. Ready in less than 5 minutes and compact enough to fit into a small backpack, Vayanis telescopes automatically handle all pointing, tracking, and focusing, all while being synced to your mobile device.
So what are you waiting for? Head over to Vayanis.com/StarTalk to learn more and be entered for a chance to win your free telescope. That's right, free.
That's Vayanis.com/StarTalk. VAONIS.com/StarTalk. Winners will be notified by November 3rd, 2023.
So, Joe, Chuck and I were in conversation before we brought you on, and weren't you at one point one of the world's leaders in how many minutes of totality you have experienced? How many minutes in the moon shadow?
Well, I've experienced. I've been in the moon shadow for just over 30 minutes. I've been to 13 total eclipses, which sounds like a lot, and for many people it is. And it would have put me at the very top of the list 50 years ago. But I must tell you, Neil, that now in the year 2023, I'm just a piker. There are some folks out there who have traveled to 25, 30, even 35 total eclipses. So I'm way, way behind the head of the pack. But still, I've seen a decent number and have experienced totality enough so that, um, as I've always told people, when you see your very first one, watch out because you instantly become addicted and you want to go see another one. And I've done that. I've seen again more than my fair share.
Did you ever cheat and go on? Do you remember they used to have the SSTs, the supersonic transport that would chase the shadow, and you'd be like in the shadow for an hour or something back when the SST was running? Were you ever lucky enough to do one of those?
No, unfortunately, I have been on aircraft which we have attempted to outrace the shadow, which of course we never really did, but we were able to extend the time of the total eclipse by a little bit. The Concorde did in fact race the shadow of the moon back in 1973 and stayed in the shadow for an incredible 73 minutes over
Whoa.
Africa. But of course now we don't have the Concorde anymore, and I'm not sure whether or not any supersonic transports are being uh, developed so that we could do that again sometime down the road. But 73 minutes, that's one heck of a long extension.
Who paid
of
that
totality.
gas bill? God, God, that was one expensive flight, man.
Yeah. So just to put some numerics on this, so the moon's shadow, correct me if I'm wrong, Joe, is what's dragging across Earth's surface, but Earth is also rotating in that same direction. So there's the speed of the shadow, and there's the speed of the shadow on the turning Earth. And I always get those numbers mixed. It's about 800 miles an hour or something. Does that feel about right to you?
Well, the moon and its shadow are moving through space at about it's the diameter of the moon, about 2,100 miles an hour. And you're right. When we have that moon shadow interact with the turning Earth, right around the equator is where the Earth can keep up with the shadow. The at the equator, the Earth is turning at about 1,000 miles per hour. So the longest total eclipses, the ones that last 5, 6, 7 minutes or more, those are the ones that occur near the tropics. As you have eclipses that occur further north, up in the temperate latitudes or up toward the polar regions, the eclipses tend to be shorter because the Earth just doesn't move fast enough to keep in touch or keep in the same path as the shadow of the moon.
Okay, so our location at New York, we're having this conversation in New York City. At our latitude, we're going east about 800 miles an hour. So that you would subtract that away from the moon speed, and that would be the effective speed of the moon shadow as it crossed over my head. That's the calculation you would do, right?
Absolutely correct. A
Yeah,
little bit of
yeah,
spherical geometry coming into play here, but
yeah.
at the latitude of New York, there was once back in the 1800s, I think 1806, there was a total eclipse of the sun that passed over central New York, passed over Cooperstown, by the way, the baseball Hall of Fame capital of the United States, and that eclipse lasted about 5 minutes. So that's about as long as you could hope for at these latitudes, at the latitude of New York,
Mm-hmm.
40 or 41 degrees north, is a 5 minute eclipse, as opposed to being down near the tropical areas, near the equator, where you can have as long as a 7.5 minute total solar eclipse.
In fact, the longest eclipse I ever saw was the 1973 eclipse, and I saw it on board the SS Canberra at sea, which was a very good place to be because you can say, oh, it's going to be cloudy where we originally targeted. Turn on the engines. Let's go somewhere else. But if you pitch tent on the ground and the overcast goes over, you're kind of stuck. So where did you see the 1973 eclipse?
Believe it or not, I was not in the totality path. I was in Madrid, Spain. So I saw a partial eclipse, but I did not get a view of the total eclipse of the
Yes,
sun.
but you were in Spain. So, you know, it's kind of a wash there. It balances it out. It balances out, you know? Yeah.
By the way, in 2026, only a few years from now, a total eclipse of the sun will be passing over Spain, and so that'll be a good place to see that totality. Think of it this way: I was about 50, 52, or 53 years too early when I went to Spain in 1973.
So for that 1973 eclipse, we were close enough to the equator for this effect to matter, Joe, and I saw 6 minutes and 19 seconds of totality.
Wow.
And which was less than had I gone further closer to the equator along its path deep into Africa, where they got, I think, 7 minutes and 20 seconds, something like that.
Well,
let me tell you how long it was. I finished a roll of film in my camera, rewound it, removed it, and reloaded and finished a second roll of film in that 6 minutes and 20 seconds. Back when film was a thing. For the youngins out there.
I was about to say, what is this film you're talking about? what is that?
So Joe, there are different kinds of eclipses. Tell me about, well, we know a total eclipse, the moon completely blocks the sun. But then, in October 2023, there's an annular eclipse, and nobody knows what these are. Could you just tell people what it is?
First of all, it's an annular, not an annual eclipse. Annular is from the Greek ring-shaped, and that's exactly what the sun is going to morph into at the middle part of the eclipse. It's kind of like a penny on a nickel effect. If you think of the sun as the nickel and the moon as a penny, the moon on October 14th, a Saturday, by the way, is going to be just a little bit too far from the Earth for it to completely cover the disk of the sun. And so when they are all aligned, the moon is exactly aligned with the sun, you will see a ring of sunlight shining around the silhouette of the moon. And that's interesting. In fact, it's rather unique if you've never seen one before, but it pales. It really does. It pales in comparison to seeing a total eclipse, because during a total eclipse, when you knock out all of the sun's light, it really is. Comparing an annular to a total eclipse is like comparing night to day. It is that different.
So the annular eclipse is kind of mood lighting. Just kind of let's dim the lights, maybe put on some Barry White or some soft music. And
you are absolutely right, Chuck. You are absolutely right.
So it's still technically a partial eclipse.
I call annular eclipses, unique partial eclipses. It is a partial eclipse. It's nothing else, because you're still going to have a portion of the sun visible. And by the way, during the peak phase, when you have that ring in the sky, you can't look at the ring unless you have either one of those special eclipse glasses or welder's glass, or you could project the image of the sun, because it's dangerous.
Right. It's still the sun you're looking at. Yeah.
Absolutely.
Whereas in a total eclipse, in the time the sun is totally covered, there's no sun there. You remove the eye protection, and there it is. Right.
Absolutely.
Right. So, Joe, we got questions from our we have Patreon supporters, and I would like to go to those. They knew that you were coming on and knew about your expertise, and so Chuck gathered them. So, what do you have for us, Chuck?
Well, let's go for it. Let's start with, hi, Neil. Hi, Joe. Hi, Chuck. I'm Stephen asking from Newark, Ohio. What is the most interesting thing you know about eclipses? Mine is the fact that we exist in a timeline that eclipses can occur. I appreciate it, and thanks to all of you for all you do. Okay.
Love that.
So what's your most interesting eclipse?
Well, when you've seen 13 of them, each one, and so they kind of like, for me, they're kind of like snowflakes. No total eclipse is alike or similar to any other. The most dramatic eclipse, I think, for me, was one I saw in 1979 in Montana, where we saw the shadow of the moon 2 to 3 minutes before totality. It looked like a tidal wave of darkness. And believe me, if you have never seen or experienced a total eclipse before, and all of a sudden you're looking toward the western sky and you're looking at what appears to be a time lapse of a severe thunderstorm. Of course, over maybe 20, 30 minutes, you see the sky gradually darken as the thunderstorm approaches. But imagine now squeezing that into a timeline of just a couple of minutes. The darkness just charging towards you, and really, there's nothing that you could do about it. You can't stop it, obviously. And here comes this shadow, which suddenly just engulfs you. It's like throwing a gigantic blanket over your head. And really, in the final 30 seconds before totality, it's kind of like, you turn down a dimmer switch. All of a sudden, the sky is dimming, and all of a sudden, you begin to see the planets pop out into view, brighter stars popping out. And when that last little bit of the sun disappears, and of course, the moon is a rugged surface. And so just before totality, you see these little beads that are called Bailey's beads. And then one final solitaire of light, if you will. And with the corona of the sun beginning to appear, it looks like a diamond ring in the sky. How dramatic an effect that is. And then that goes away. You have the corona. You're suddenly enveloped in the weirdest light that you have ever experienced in your entire life. I can't even tell you. You may have seen beautiful sunrises and sunsets and unusual sky colors, but there really is nothing to compare to having totality sweep over you. All around the horizon, the sky appears like a saffron color, high above your head, kind of a navy blue in color. And everything is changing moment by moment. As the shadow is passing over you, you see everything shifting and changing, and it's just an incredible and an amazing sight to see.
Yes, but Joe, tell us how you really feel about this.
I know, that's what I'm saying. Look, Joe's got it real bad. He's got it bad on that one.
That was amazing.
I was in Idaho, in the mountains of Idaho in 2017, and I looked for the shadow approaching, and it is scary, frightening, and exhilarating all at the same time. But I have to tell you, Joe, for others to know, only when you've seen eclipses before do you have the luxury to not look up 30 seconds before totality. You know that there's other stuff to notice. And so you look down and around. Most people in their first time, they can't possibly notice that, Joe, right?
Well, there's so many different things that are happening. You're absolutely right, Neil. About 30 seconds to a minute before, there are people who have spread a white sheet on the ground because there are weird-looking shadows called shadow bands that are flickering across that sheet. And the reason why we see them just before totality and right after totality is that the sun, just before totality, is suddenly a thin filament of light. Now, you know that when you look up at the sky at night and you see the stars, they appear to twinkle. They twinkle because the little light beams coming from the stars are passing through our atmosphere and are being distorted by our turbulent atmosphere. So that gives the effect of a twinkling effect. Now, the sun does not appear to twinkle when it's out in full view because it's a full disk. But when we have it narrowed to a thin, very thin, narrow sliver of light, then the atmosphere, the turbulence of the atmosphere allows that to kind of interfere with that thin sliver. And what you see there on the ground are, again, really waves of light and dark that are racing across the sheet or racing across the ground. And that's an effect which, really is kind of there was a total eclipse of the sun in India back in 1980. And people, the uninitiated who were looking down on the ground during the moments just before totality, they were screaming, "The ground is on fire! The ground is on fire! Look at what's happening to the ground!" It's just another one of these amazing things and amazing effects that happen right around the time when the sun is getting ready to go away for a relatively short interval of time.
Yeah, so the luxury of knowing what to look for rather than just staring up at the night sky.
Yes.
Yeah, totally. And so for me, what I like is what's that? Do I get to answer that question too, Chuck? Do you think?
Yeah, go ahead.
Oh, don't say it like that. Say it like that. Just that when you're in a lightly treed area, like you have the shade from a couple of trees, and you see these sort of dots of light, this modeling on the sidewalk. I'm in the city, so it's sidewalk. The light is on the sidewalk. You say that's just light. That's just sunlight peering through. No, it's more than that. It's actual images of the round sun on the sky that are being projected through a pinhole effect onto the ground. And you know this because if there's an eclipse going on and you look back at that light, it all have these little crescents. And you can watch the eclipse unfold on the ground. And Joe, I saw someone in Sky and Telescope, they took a colander from the kitchen, which has hundreds of holes on it, right? And then they held that up in the eclipse, and you see all these hundreds of little eclipse lits. Can I say that? Eclipse lit? Is that allowed? Okay. So that's my favorite part is seeing the multiple images of eclipses on the ground made by things that are just otherwise shadows of leaves that you wouldn't otherwise know to think about.
My wife and I had dinner at a diner just about a week ago, and I had chicken noodle soup, and they brought it along with some saltine crackers. And I took the crackers and I put it in my pocket. She says, "What are you doing?" I said, "I'm saving this for the eclipse that's coming up, because you
Joe,
can
can't take you anywhere. Can't take you anywhere, Joe.
you could use a saltine cracker which has these little holes in it. Use that and project the image of the sun through the holes, and you have a little eclipse projector using a saltine cracker."
Yeah. Yeah, doesn't work with a Ritz though, huh?
Oh, Ritz. Well, do Ritz have holes?
Yeah, they do.
Yeah,
But they don't
do
go
have
all the
holes.
way through.
Yeah, oh, okay.
Saltines are pierced all the way through. The Ritz
I
are
Okay.
didn't
more
know
like,
that Chuck was a cracker expert here.
yeah, more than you know, Joe.
Let's move on to the next one real fast.
Yeah, there you go. By the way, let me just say, Neil, you just answered Justin from Ontario, Canada's question without even knowing it. And
What's
he
that?
asked the exact question of why is the image on the ground when it's projected through leaves? And
Yeah.
he ended, Justin from Ontario, Canada, ended by saying, Neil, you are like the stars to me. I look up to you. So just wanted to give him
thank
credit
you.
for his question that wasn't even asked, but was answered.
Okay. All right,
Fantastic.
you got it.
Okay, so this is Liam from Rhode Island. He says, do you know if there's any effect of solar eclipses on wildlife? I am wondering if there have been any interesting behaviors that have been documented when the sun goes dark in the middle of the day.
All right. Joe, what do you got for that?
Well, we have had indeed studies on that very subject. In fact, in 1925, when there was a total eclipse of the sun right here in little old New York, there were people at the Bronx Zoo who observed the animals, who took note. The deer, for example, raced around in panic just before the sun hit totality. In the cage where they kept the chimpanzees and monkeys, they were, having all kinds of fun, jumping around and everything else. But then, just as totality was about to approach, they got very, very quiet, and they looked around, and they almost looked like they had a scared look on their face. They said, "What's going on here? It's getting dark." But the most interesting thing was that there was a very rare bird called the bird of paradise, and the effect of the eclipse on that bird was such that during the time frame during totality, the bird actually stuck out its neck real far and extended its wings out, and just was going up and down, up and down. And the people who study these birds never saw anything like this before. It does have an effect. Chickens go to roost. In fact, probably the most famous story about this involves Thomas Edison, the great inventor. He saw a total eclipse of the sun in Wyoming, just as you went to Wyoming, Neil, back in 1879. And he had a device that he was going to use to measure the temperature of the corona that he had just invented called the tasometer. And he was looking around for a place where he could set up, and he saw an old barn house. And he looked around, there's nothing in there, and he says, "Oh, this is great, and it'll protect me from the wind and provide me with shelter." So he set his instrument up, and here's totality coming. It's only a few seconds away, and all of a sudden, from all directions, Edison got bowled over by chickens that were coming from all directions and going back into the barn house or the hen house to go to roost because they thought that nighttime was coming.
Oh,
and so all of a sudden, that was one of the world's great chicken stories, I might add.
There was also an eclipse that went across near South Africa and went over the Kruger Game Reserve. And so there are people who were, I don't know what results came out of that, but the Kruger Game Reserve, where, there's hippos and giraffes and, the things that are in half the dioramas of the American Museum of Natural History, the watering holes. So I knew people were going there to see what the effect is. I would say the animal that behaves the weirdest of them all is humans. We spend scads of money to go into the shadow, take boats, trains, planes, and automobiles, and we've got to be the weirdest behaving creature out there.
The first 30 seconds of totality, as long as the totality lasts at least 30 seconds, but the first 20 or 30 seconds, people just scream their heads off. And then after the initial shock and the initial screaming and yelling of, "Look at that, look at that," everybody quiets down. And if they have an experiment they're conducting, looking at temperature sensors or whatever, or taking pictures, everything gets very quiet. And then just as you approach the end of totality, you start seeing the interesting thing about the end of totality. There's like a red flag that comes out that warns you that totality is about to end. The chromosphere, which is the innermost part of the sun's atmosphere, which glows kind of a beautiful reddish or electric pink color. first begins to emerge, and that emerges maybe about 5 or 10 seconds before the actual chromosphere, the first part of the sun's surface emerges and comes back out. And of course, then you have to put your glasses or your protective devices back on your eyes. But it is an amazing spectacle, literally from start to finish.
Chuck, give me some more.
Okay, here we go. This is Will. And Will says, greetings, Joe, Neil, Chuck. What is the earliest record of an eclipse, and what might have prehistoric humans thought was going on? Thank you all so much for what you do. Will from Lexington, Kentucky. Yeah.
Any speculations there, Joe?
October 22nd in the year 2137 BC, believe it or not.
Wow.
We have records of an eclipse that occurred over China. And the interesting thing about that eclipse, Chuck and Neil, was that back then, in those days, they actually had court astronomers. Now, back in 2137 BC, they could not do any specific calculations, but the court astronomer's job was to constantly watch the sky day and night for anything unusual. And in the case of an eclipse, if you saw that there was an eclipse taking place, you immediately alerted the emperor, who in turn alerted the people, who would then beat drums or shoot rockets up into the sky to try to frighten the dragon. They thought that was what an eclipse was taking place, an invisible dragon eating away at the sun. Oh. And in 2137 BC, unfortunately, the court astronomers apparently were asleep. Either they got drunk the night before and didn't quite wake up in time, but didn't alert anybody that an eclipse is in progress. And here comes the eclipse, and here it's getting dark, and everybody is screaming and yelling and running around, shooting rockets. And believe it or not, they did actually scare away the dragon. That methodology always worked.
It works every time.
It worked every time. But after the eclipse was over, the emperor said, "You have sinned an awful sin. You did not warn us about this event. You didn't tell us that the dragon was coming and eating the sun, and so you must face the ultimate price." Oh, and they were beheaded. That was it. And that presumably is the earliest record of a total eclipse of the sun over China, again, before the Christian era, 2137 BC.
And of course, China kept very good records of the nights of the sky. I mean, that's some of the best records we have.
Absolutely.
Around the world, going far back. I have a case where someone called me at my office, and they found a diary in the attic of her grandfather who had just died, and that diary was of his grandfather, who was a pastor. And if my timing is right on this, I'd have to recheck my numbers. But so apparently it describes that they are moving through Massachusetts in some kind of wagon train, okay? And all of a sudden the sky got dark. And this is, by the way, described in Revelations. The sky gets dark. And the pastor was certain the end of the world was near. He stopped the wagon train, got everybody off, and said, "Repent. The end of the world is near. Pray for forgiveness." Everybody got off, prayed, then it got light again, and then they felt that their prayers were answered. So she asked me, could this have been an eclipse? And I said, even deeply religious pastors would have known what an eclipse was because they're educated people. An eclipse is not a new weird thing in the sky. They would see it, say that's an eclipse. Okay. So I had to conclude. Well, at first I went to verify that it was real. So I checked. I said, when would you? She said between 1760 and 1790, Massachusetts. So I went to my tables and went to my computer, found, yes, indeed, there was a total solar eclipse that crossed New England in whatever year it was, but I had the correct year, and that tightly localized that trip, okay? Because eclipses are not rare, but when they do happen consecutively, they're all around the world. So I nailed that. So I said, yes, they experienced an eclipse. But if he didn't know it was an eclipse, it must have been overcast. Because if it's overcast, the sky just gets
see the sun and everything just got dark.
Yes,
everything just got dark.
Right. I experienced that a couple of years ago. I went all the way down to Antarctica to see a total eclipse of the sun. And down there, it's almost 24 hours of daylight in December, which is the month that I went. And we had total overcast, complete total overcast. And came the moment of totality. All of a sudden, the sky got very dark for about 90 seconds or so. And then just as quickly, it got bright again. We had a gray sky, but that was the shadow passing
froze
overhead.
your buns off for no reason.
Actually, when I was offered the trip, I said no, because I knew that the weather prospects for clear weather was lousy. But the people who put the tour together said, you're missing the point. The eclipse is the icing on the cake, but the trip itself is the cake. How many times are you going to get offered a chance to go to Antarctica? And so we went. My wife and I, we spent 2 weeks down there, and I got to tell you, it was interesting. I mean, cavorting around with. We went to a place called Paulet Island, a 1 mile slab of rock, 200,000 penguins on that island. I mean, and the funny thing is, they told us, stay at least 5 meters away from the penguins. Do not go near the penguins. Somebody forgot to tell the penguins that. And in fact, if you go down to Paulet Island, they waddle up to you like a pigeon will waddle up to you in Central Park. You know, just looking like. So I didn't see the eclipse, but I saw a lot of penguins.
Okay, all right.
Yeah, that doesn't sound like a good vacation, Joe.
It was interesting.
I'm just going to be honest.
And by the way, penguins don't poop less than pigeons do, right? So there's surely penguin poop everywhere. All right, we got time for just maybe 1 or 2 more questions. Chuck.
Okay. Hey, Neil. Hey, Joe. Hi, Chuck. From the world of falsifiable hypotheses, how does a flat earther explain a lunar eclipse? From Backwoods, Oregon, expiring minds want to know.
So, Joe, take a stab at that. I got something to say too, but I want to hear I want you to lead off.
A lunar eclipse is different from a solar in that the moon. The sunlight provides the light that that allows us to see the moon, reflected sunlight. When we take away that sunlight, then the moon disappears. And the only way we could take away that sunlight is if the moon were to move into a shadow, our shadow. The Earth, of course, if you believe that the Earth is a globe like this.
Blasphemy!
And a globe will cast a shadow out into space, a circular shadow. So when the moon starts moving into the shadow of the Earth, you see a curved shadow moving across its face. So if this is a flat Earth that we all live on, how is that possible that we get a curved shadow moving across the disk of the moon? And so that's the best way I know to describe or to prove that we live on a sphere, on a circular planet.
But you left out an important point there, Joe, which is it is a curved shadow no matter where the moon and the sun is on the sky during that eclipse. And so you have to ask, what is the only shape that will always give a circular shadow? And that's a sphere. Right. Whereas a disk can give a circular shadow, but at other orientations, horizontal, then it's a straight line. So that's what we would tell flat earthers, but they're not going to listen.
No, there you go. And that's the truest lesson there, which is don't waste your time. That's the real lesson.
One more.
Okay.
What else you got?
G'day, Dr. Tyson, Joe, and Chuck.
Okay.
That's the way he says it. So anyway, but then he says Andy C here from Vancouver, British Columbia. So maybe he's just an Aussie in Vancouver. Who knows?
Because only Aussie said good day.
Yeah, that's right.
Sure.
And he spelled it good day. He didn't.
Good day. Yeah.
Good day. Anyway, a historical question here. What do we know about how ancient and early culture civilizations conceived, interpreted, and understood these rare events? Did they actually mean something? What stories and legends and myths revolved around them? What is the most interesting myth or magical moment associated with an eclipse that you would know of?
So other than the dragons eating the sun,
right?
What else is floating around there, Joe? Before the era of science,
there were 2 warring factions in the Middle East: the Lydians and the Medes. They were going at each other for many, many years. And then all of a sudden, right in the middle of a battle, the sun suddenly darkened. A total eclipse of the sun took place. And both factions were so frightened at what they saw, they thought that a message was being sent to them from high above. They immediately called a truce, shook hands with each other, and never wore it again. It's too bad that can't happen today.
Wow, that's a great story. Oh, man, that's so cool. I mean, I just love the idea that they're on the battlefield going at it, just like, I'm going to kill you. And then the sky goes dark. And they're like, hold me.
Hold me.
Hold me, please hold me.
It's kind of like a football game, a playoff football game where both teams are going at each other and trying to kill each other, and then one of the players gets hurt very seriously.
Yeah,
and
that's true.
Both teams come together.
That's true.
And they both have their heads in. I've even seen cases where both teams pray together as the guy's being carted off the field or whatever. Mm-hmm. It's maybe something like that.
Maybe they should try that prayer before the game, and they would prevent something.
So, Joe, in your eclipse that took place over that battle, I think there's an addendum to that eclipse, which is we know exactly where that battle was being conducted at the time. And if you take modern eclipse tables and go backwards to post-dict that eclipse, the eclipse lands in the wrong part of Earth. And so you say, well, could they be wrong about where they held their battle? Rarely do you not know where you're fighting other people and laying bloodshed. So they had to correct for the slowing down of Earth's rotation to properly land the eclipse in the right spot. So that is one of the longest baselines of evidence that Earth's rotation is slowing down. The eclipse stopping that battle in that moment at that location on Earth. And so that's the moon sloshing tides on our continental shelves. I've been doing that forever. And you have to factor that in if you're going to back predict eclipses into the calendar.
Look at that.
Yeah.
Cool.
Yeah. So, Joe, you carry so much eclipse expertise, and we're doing what we can to share it here. But I understand you offer virtual presentations on eclipses to libraries, civics groups, organizations, and you are available to do that before the April eclipse of next year. And from my notes here, I say it's an hour plus, of course, Q&A. So what kind of things do you do in that hour?
I'm offering actually two different presentations. One of them is called "The Sun Will Darken" on April the 8th. We know why. There's a total eclipse, but I get into
with a title like that, though. You sound like you're trying to get the superstitious people to come in.
Well, there are a lot of people who still, even to this day, get frightened by total eclipses. But we get into the mechanics of why we have total eclipses of the sun, and then I get into also the proper way of observing eclipses, especially the partial phases where you need some special device like welder's glass or special eclipse glasses, or if you want to project it through a saltine cracker or through leafy trees. The other presentation is I call Adventures of an Eclipse Chase, and I talk about not all but some of the crazy things that I've done in order to see a total eclipse of the sun. For example, just one example, a few years ago, I convinced a major airline to change the path of a commercial airline flight from Anchorage, Alaska to Honolulu, delay the flight by about 30 minutes so that we could be in the proper position over the Pacific Ocean so that everybody on board the flight would be able to see a total eclipse. We would encounter the shadow of the moon as it passed over the Pacific Ocean. And this is just one of the many different things that I've done. I'll do anything to see a total eclipse. And that was one of the crazy things.
That's a version of hijacking the airplane.
I was about to say, you hijacked the plane. You know that, right?
You hijacked the plane. Just say it. With
the permission of the airline. With the permission of the airline.
So we can find you at, Rao is R-A-O. So we can find you at Joe Rao Weather at Gmail. They can just send you an email. Is that right?
joeraoweather@gmail.com. Just send me an email and I'll send you back all the information about how your library or how your civic group can get hold of me and have me give a presentation. And I think I'm going to become a very busy person as we get closer and closer to that big total eclipse coming up in the spring of next year.
when eclipses come, I hide. Okay, so it's all you. You got it. It's one day. Others can take over, and I can rest for a day. That's how I think about it. So at Joe Rao, RAO, Joe Rao Weather, as in weatherman, Joe Rao Weather at gmail.com. Joe, I'd be delighted to catch more of you through those channels. So. Was that everything you never wanted to know about an eclipse, or or never knew you could know about an eclipse? Chuck, how are you feeling eclipse fluent now?
Yeah, I'm going to say no. I still don't. There's not enough. I could do more of this, to be honest.
Oh, yeah. Okay.
Eclipses. Is there anything they can't do? I mean, they stop battles. They get weathermen to hijack planes. They behead Chinese court watchers. I mean,
all right, Joe, great to see you again.
Great to see you, Neil. I have a feeling we're going to be seeing a lot more of each other as we get closer to the big day next year.
We will totally find reasons to make that happen. All right. This has been another episode of StarTalk, a hybrid interview and cosmic queries. I love them. Chuck, always good to have you, man.
Always a pleasure.
This has been StarTalk. Neil deGrasse Tyson here. As always, keep looking up.